Good afternoon, everyone. Thank you so much for attending our talk. My name is Eder. I'm happy to be with my friend here, Elder. We both work for Red Hat. And I spent my first 15 years of my career working mostly with Java, and I used to work on the Rose Team framework, and I built multiple open source projects, libraries. But then, after all those years, the AI revolution began, and I decided, because for me, technology is something that I'm passionate about, and I decided to jump on this wagon, because I think AI has a chance to really transform the way that we build applications, especially the way that technology is applied in our world. So I decided to join a new team is OpenShift AI. OpenShift is a Kubernetes distribution by Red Hat, and we are building OpenShift AI there. And myself, as a Java developer, I have to learn a lot of stuff on this journey. I joined them last year. So I'm here to share with you. So what are our goals with this talk? First, to bootstrap understanding of how MLOps platform works under the hood. MLOps is by machine learning operation, so we are going to learn about this. We're going to understand, especially the most important thing is how people put models in production. So we talk a lot about AI, but how actually people put those models in production. We also are going to see how Kubeflow is the project, open source project that I've been contributing my entire day right now. How simplify these machine learning workflows. Also for everyone, where the Java fits into this picture, and after how Quarkus is, in my point of view, the best way to build a Java AI application. So we all know how 10 years ago or 15 years ago, I used it to deploy Java applications building in my machine and doing SSH for the server and just copy in the JBoss EAP. Was a wild times, but the DevOps movement come and change the way that we build software. So we started to have our pipelines that do the testing, do artifacts, and all the deploys are doing automatically. And this put a lot of sanity in the software development process. So people that are starting right now, they cannot imagine how we used to build stuff and put stuff in production, doing SCP and connecting the servers. And the DevOps movement that is well established right now really changed the, oh, there is something here. Oh yeah. Where's the mouse? The mouse here. Allow, should click here. Yes, thank you. So, and DevOps, we know that is the way for us to put software in production, but how this apply for MLOps? With machine learning, putting models in production is more complicated. It's a different beast than DevOps. It started because it introduced a new persona that's besides just before on DevOps was the developer and the ops that we need to talk. In machine learning, we have another persona that is the data scientist. Is the person that are going to do the model, to write the model and do the research that you pass for someone that they are calling right now machine learning engineering. Sometimes it's an engineer and sometimes a data science, sometimes they're both working together that pass this model for production. But why putting data science models are so hard? Basically, what makes models different from our current programs written in Java is that in models, the data is constantly changing. What is this? You have a model that works in your company, is trained with the data from your company. The model can be predictive and understand if an operation is fraud or not. But imagine if your company open a new business in another country, it will be new data, you'll be new type of transactions, and the model needs to understand what is a fraud or not in this case. So models needs to be constantly trained. Another different in models is that the models mostly are non-deterministic. So different from our Java programs, models are probabilistic data structures mostly. So the output vary depending on what you call. Most important for put things in production, that is my area. Training, tuning, and deploying model requires really heavy computer resources. We are talking about thousands of GPUs. We're talking about thousands of big clusters, especially when you go to large language models, when you need to train and run those. Most of the models you cannot run in a user machine. When you're talking about, for instance, LLMs, when you're talking about a real model, take what DeepSeek is doing, for instance, you know that it's impossible to run in a user machine. So how you build a cluster to do this? And collaboration, as I mentioned, is much more harder in data science because we need data science engineer and ops all involved. And what is MLOps, machine learning operation, that we just call MLOps right now, is take all the DevOps principles, practice that we established on the last 15 years of development and applies for machine learning to make the fact of putting models in production become scalable, reproducible, and automatable. But before jumping on all the theory and all understanding how people build, I'd like to just do a quick recap. If you know, like this is the third talk in the event talking about AI, just give me a pause. I'll take 5 minutes just to recap some vocabulary that I'll use under the talk. First, this will be super quick. First, what is a model? A model is a program that takes an input, like a text, image, or a data, and produce an output. Or mostly simply be fraud detection. So you have a model that's kind of a program where you pass the data for a transaction, like a user pass a credit card. You pass all this data for the model, and the model replies if a fraud or not. What is inference, this word? Inference is the process of when you use a trained model to make predictions. So inference is the act of your calling the model to use to get the data back. This is the word that they use, is inference. The third word, and that we need, Java developers need to, there's a microphone, yeah. No. So now they have to pay attention because a thing that confuses me a lot. That feature in a model is the properties that they are using as an input. You know the name for this, we call this parameters, but don't call this parameters. This is where the confusing starts. When people in data science, they are talking about features, are the values that we're passing for input in a model. If you're talking about fraud detection, we are passing the data, like the transaction amount, the location where the user paid the card, and the number of the transaction in the last hour. The next topic is what are parameters and hyperparameters in the machine learning in data science space. Parameters are what is the internal variables and internal values that your model figure out during training. The name that they use this is the weight and bias for your neural network. So when they are talking about parameters, they're not talking about our Java parameters. They are talking about the variables that the model trained. If you remember the class when you're putting to do a curve, for instance, is the variables that you put over the x in an equation. Is the variable, these are the parameters the model learned this. And when people talk about hyperparameters is the configuration that a data scientist uses to train the model. So it's like the config files that they use to train the model. The next concept is what is model training? Model training is when I'm creating the model. I take a bunch of data. Usually I take that data, like multiple millions of transactions, and I put labels that telling that the transactions are either fraud or is not fraudulent. And then I use this data to train my model. Again, this is just to create vocabulary to us to say the same thing. The next topic is what is model serving. Model serving, when they talk about model serving, is the fact to add a model to a running to become an endpoint. So you are taking a model, packing the model in a runtime engine, deploying the model somewhere, in our case it would be Kubernetes, and your model is actually behind the endpoint where you can do REST calls for ease, and the REST call when you do is actually an inference. So when you're doing an inference, you are calling a model that is serving in a platform or model serving, okay? And passing the features that are our parameters, that features for the model. And the second and the last thing that is the most important part when I talk about putting things in production, this is the easy way for us. What is model registry? It's a place where people put multiple versions of the model. You can remember that models need to be retrained. People say, oh, models need to be retrained because data is changing constantly. So you need to retrain your model for your company like every week. Because a model that works today, as soon as new data enter in your company, you need to retrain the data to learn that the new data is fraudulent or not. When you have multiple models, you need to figure out 2 weeks ago which model was deployed for auditing, for instance. And you use this to put in a model registry. Don't tell others, but this is kind of like the Maven repository for us, when you put multiple versions of the things. And how this connects everything together. Don't be scared about this picture. This picture are going to go over the whole talk. So start in the left here. The machine learning engineer or data science, depending on who you are talking, call this name, start the data preparation. The data preparation, you take a bunch of the data, imagine that the data from multiple databases, you clean up this data and put this data in the same format. Usually people do this with Spark, because Spark is good to handle multiple, huge amounts of data. Next, go for the model development, the next green box here, the second one. Model development usually in production, people in real world, people don't build a model from scratch like we do in tutorials. They take a pre-trained model and put their training data on the top of a pre-trained model. And usually the person that do this is the data scientist. Once you have a model in data science that's probably running Jupyter, that is the ID that you show later, go for the next step, that is a model tuning or model optimization. This is 2 weeks. Remember, they were saying the hyperparameters are the configuration of the model. People try with a lot of configurations to try to figure out what is the model that provides the best input. Nowadays, this thing is almost automated because there is a bunch of open source projects that open a tree of possibilities, play with all the parameters, train multiple models to have one model as output. So that's why when you talk about Kubernetes, you understand why people are doing this. Like data science hand over one model that kind of works, and then pass for a machine learning engineer, spawn like 100 of training data to try to figure out a best model, and they do this via auto-tuning. Once a model, we have a good parameters in the model, we do the real training. That is the last, second from the last. Model training is the fact of take all the real data and then do the training. Most of the times, this involves multiple machines, so we cannot do model training in just a single machine. The way that people usually should do this in production, if you are familiar with Kubernetes, is like Kubernetes job. So we spawn amount of Kubernetes jobs, split the workloads to train a small amount of data in multiple jobs, and combine those jobs in output. And in the end is the model serving, is the fact that I'm serving the model and finish the loop. Why there is this repeatable process that we call a pipeline? You see the box here in the end that connects everything together? Because as I mentioned, in production, people are trying to do this every time. So every time that usually they take an endpoint from the model serving and see if the fraud is for instance, 90% of the frauds I'm able to see is a real fraud or not to detect. There is one thing that's called a model drift, for instance. The model starts to perform lower and lower because there is new data coming in your software. As soon as pass as a threshold, usually people monitor these Prometheus. What you want to do as a software developer, remember the pipeline. You're going to re-trigger the pipeline. So you do this in automatically way that as soon as the new data coming from your Kafka or something, you're going to re-trigger the whole pipeline. So this is the way that people are building the same principle that you have in DevOps, but do this for model training. And next, what is Kubeflow? Kubeflow is one. If you're interested in this, Kubeflow is your best place to start. It's an open source community that I'm part of that have multiple projects on top of the Kubernetes to help you simplify and combine all this MLOps lifecycle working on top of Kubernetes. What are the advantages of it? There is a technical advantage because there is multiple companies working in the open source. Like 15 years ago, people built together, multiple companies built the Kubernetes. Now there is a bunch of companies, Red Hat, Apple, NVIDIA, Canonical, we are all working in Kubeflow to build a platform for AI workloads in the top of the Kubernetes. But how this works out? We have a bunch of components. The components that we're going to talk are the components in the middle, and we have a bunch of ecosystems. Probably if you are an engineer, what your data scientist asks are the things on the top. So your data science you want to use PyTorch, TensorFlow, this sort of stuff. What are the components in the middle for the Kubernetes? For Kubeflow. Each of that steps is one of the Kubeflow project that we combine together in order to put sanity in the machine learning lifecycle. And in the lower is the infrastructure, because you are built on top of the Kubernetes. We are able to have multi-cloud. So on the Kubeflow community, we have Azure, you have Google to do the Google Cloud, you have Amazon, everything, and Red Hat, everything works together. So everything that you know that run Kubernetes could be in your machine with kind, like I do, will run also Kubeflow. And from the bottom, what's the most important part for you and data science if you're going to do this? is that the graphical cards companies, they are working together to make Kubernetes and Kubeflow work well with graphic cards. So NVIDIA, for instance, are giving operators, this will be a little down over Kubernetes, but giving a way for you to share expensive GPUs in a Kubernetes cluster, and then you can consume the GPUs by the data science and have a time sharing loading for each GPU, especially when we are talking about, for instance, 8100s, it's like $30,000 one GPU. So you build a cluster in a Kubernetes cluster, and your GPU become a resource that is accessible for all the platform. Another advantage is that there is a bunch of companies going there. So we have Red Hat, IBM, Google, Canonical, everyone is working together in a true open source value, and we are building best with the community, because we know that not a single company can build a platform like this one, so we are building all together. And what I do at Red Hat, just for disclosure, I work in OpenShift AI, now you understand. We take a bunch of open source projects. One is the Kubeflow, we build our midstream, that Open Data Hub, that is OpenShift AI. The things that I'm going to talk about in this talk is just Kubeflow. So there is OpenShift AI, is just the skin that we put to look like Red Hat products, but I do everything open source. Me and my teams, we all work only upstream. Coming back, what is each Kubeflow component? When you talk about data preparation, we have a Spark operator that you put Spark to work on the Kubernetes cluster as an operator. So you'll be Kubernetes native in a good way. When you go for the notebooks, we're going to talk soon about what are the notebooks. We have my favorite project. There's a way for you to do model development. Basically, what notebooks does is a notebook as a service. We're going to see this in a second. On the Kubeflow, we have Katib. That Katib is a project to do automatically machine learning to find what's the best parameters and height parameters for your model. We have Kubeflow Trainer. There is an abstraction of Kubeflow jobs, but for the machine learning use case. And we have Qserve. How you're familiar with Knative here? Knative is the serverless part of the Kubernetes. So Qserve uses Knative, does what our Knative does for our applications, to be serverless, to scale from 0 for thousands, but for the machine models. And in the end, we have Kubeflow pipelines. That is a pipeline based on top of Argo CD that makes all the projects talk together, okay? And where Java and Quarkus, that will be Elder, that's the expert, fits into this picture. In my point of view, when you're talking about that box there, that looks small, that box, because we're talking here about machine learning operation, but that's most of the use cases are in that blue box in the top, is when I put things on production. In my point of view, and others agree, Quarkus is so good to talk with the Kubeflow, and because it's Kubernetes ecosystem. So as Kubeflow is on top of a Kubernetes, Quarkus is the best one to use to write your Java application, because you can consume everything, because all those projects here that are listed, in the end, everything is a Kubernetes project. It's just a layer on top of the Kubernetes, and Quarkus speaks pretty well with those projects. Now, I will do a small deep dive in 3 of my favorite Kubeflow projects, because there is a bunch of them. I can spend like a workshop for hours about this. I will talk about the one most important, I think, that is the Kubeflow notebooks. Kubeflow notebooks is where your data science lives, because there is no way for us engineers that you take the data science out from Jupyter. But the problem is that how we do Jupyter as a service, the models currently we cannot run in user's machine because you don't want to do this. And how we do this in reproducible manner? Use Kubeflow notebooks. Basically, is a way for enable people to do model development, exploration, and pipeline creation directly inside Kubernetes. So there is a why that we do. This is the Kubeflow why. We have a user can go there, create a notebooks. I will show this in a demo, and we have a list of the notebooks. Each notebook is spawned based on an image. Here I have 2 images. This is running inside in the browser. Okay. So in the right I have a Jupyter notebook, in the left I have a Visual Studio Code, for instance. But see that, imagine that you can run any IDE and any image in the cloud. What is the advantage of this? We can do this as a service. This will become something that is using in sharing the Kubernetes resource. Kubeflow notebooks will give abstraction, for instance, where we can choose an image on the top, And from a Docker image, you can have thousands of images that each image has pre-configuration stuff. You can choose, people that know Kubernetes start to recognize, you can choose the size of the machine. That will be what's the size of the machine that will spawn in a container in deployment in Kubernetes that will be associated. And also we can share GPUs. In the top here, we can have GPUs. So we can have a Jupyter running as a Kubernetes resource, and you can have all the advantages of running inside the Kubernetes. Everything behind the scenes becomes a Kubernetes custom resource. What is a Kubernetes custom resource? It's a way for you to teach Kubernetes to do then deployments, to do all the infrastructure based on a custom resource. Custom resource is something that you put a controller in the Kubernetes to learn that when you do this file, we are going to spawn one image you can see there with this resource, with this memory. So Kubernetes controller will do the deployments. And if you see here, I'm creating a deployment. This is my Kubernetes cluster here. We have a pod that is a Visual Studio Code instance. And inside the pod, we are creating a sidecar with Istio, and you are creating the container there. So everything behind the scenes will become Kubernetes. And I will show this as a demo, but it's a way for you. Why people love this? Because it's easy to use. There is a shared storage, and people can share resources in Kubernetes. So in Kubeflow notebooks, you have a way to give people resource and freedom to reuse things and do machine learning at scale in a cluster. The second project that I want to highlight quickly is the Kubeflow pipelines. A pipeline, as I mentioned, is a way to automate multiple steps of machine learning training. And how Kubeflow pipelines work. Each step of a pipeline will become a container in the end, because we are doing everything in Kubernetes. So each step of the pipeline is a container, and behind the scenes, we use Argo workflows. Who here know Argo? Argo is the thing that runs everything that you touch on a Kubernetes or pipeline. There is a good chance that it's running on Argo. So we create an abstraction on the top of Argo that each of those steps, like I'm trying to do a reproducible step, everything will be a container, and everything will be run inside Argo. And a task, for instance, for a pipeline could be data ingestion, feature engineering, model training, and evaluation. So you have a pipeline able to re-execute this as you wish. So if there is new data coming, you run the pipeline, you do all the steps to train the model, to deploy the model, and serve the model. And you can do this repeatedly. There is multiple ways to create pipelines. One way is with Kubeflow Python SDK. So there is one SDK that you can annotate. This is mostly in Python because it's the data science thing. But my favorite one is one project that I contribute called Elira. Elira is a drag and drop way to do pipelines. So here I have inside the Jupyter, see I'm running, Elira works in Jupyter. So I will create a pipeline that will load the weather data from multiple sources. After I load the weather data, the next step will be to do the data cleaning, because imagine that you take weather data from multiple sources, you have to put everything in the same format. And the output, I'm doing two types of the model with two technologies to figure out what is the best one. When you run a pipeline, looks something like this. This is the Kubeflow central dashboard. This is our UI for Kubeflow project. So you see the steps that you work in, and each step is a container. The thing is like, imagine that you have this, that you provide a model that can classify the weather. In the end of the pipeline here, you choose what's the best model, because you're training two to figure out what's the best. Imagine that 3 months from now, something changed and the weather become unpredictable and your model is not responding pretty well. Instead of asking a data science to do again everything by hand and put the model in production, remember in DevOps, when you do, before DevOps, you build things in our machine, push for the server, put on Widefly and do the deployment. Now we just push on the Git, on the DevOps, take the commit and the pipeline of DevOps, put the things in production. The pipelines here is the same. Because if I want to generate a new model, I run this again, we will load the weather data again from the website, push, do the training, and figure out what's the best model, and put the model in production. So with MLOps, we're trying to automate this. Everything run inside a container, as I mentioned, so you can go there and see what's going on in the logs. And as is the container, everything is ephemeral. You can scale as you wish, and usually people put the output and output of the containers in a shared storage. This could be S3, or this could be any S3 compatible store, like Mini or running inside the cluster. So people put the model data or model that's coming, put the output of each step, and each step have access for the same Kubernetes storage. And the last for this drive-through is the key-serve. Key-serve is the entry point for the AI applications, is the serving, is where I take a model and I serve the model for the AI application. This will be pretty familiar for you all. This is a key-serve deployment. It's called technically a key-serve data plane. Data plane is how this thing works behind Kubernetes. So when your Java application is doing a predict for an endpoint, this you have a service in the top, a Kubernetes service on the top, and the service could be canary or to see if a canary deployment or not. But behind the scenes, we'll go in a single box that we call inference service, and this box could have a transformer, but transformer is optional, but the most important box is a predictor. Predictor is where your model will be running inside Kubernetes. So when your Java application calls this endpoint, we'll go through a predictor and you get a response. What is the advantage of using key-serve? First, key-serve is like Knative and scale to 0. So in your company, you can have thousands of models and not all the models are called all the time. So because it's Kubernetes, the Knative, you scale down to 0, and as soon as the model is called, Kubernetes starts a new pod and put the pods on. This is the definition in the end, and let's go for the demo and see if the demo works. Let me try to do this again. I try to show this. Sorry? Oh, yeah. We work. I trust you. Let me reduce this. I can go here. I will use OpenShift AI here, but just because I have a bigger cluster than a Kubeflow and I have graphical cards, so things works, but everything that you see here is Kubeflow in the end. Trust me on this. So when people do a provisioning, for instance, imagine that the user, this is the workbench that the Kubeflow notebooks we are seeing well, right? You can go here and have a click. Imagine that now I'm a data scientist, okay? I go for your application and say, I would like to do a model deployment. I'd like to explore a model. I will create a workbench here. I will pick an image, and then I will see a container size. That's why I use my cluster. See that's the size of those things. And also the GPU. So we have GPUs shared here in the cluster. You put now NVIDIA has a bunch of work with the Kubernetes community to put appliances of NVIDIA inside your cluster, and your GPU will become a resource like a storage, and you can share resources with multiple people. And so when you do this, you actually open here. I open to. I have to do login, logically. So here I have a Jupyter instance running, or do a little bigger, yeah, running inside a Kubernetes. If I go here and I see like KNS, you see here, for instance, the Visual Studio Code that is running here as a deployment. And if I go inside a container, I see the container here, I can go here and go to the logs. So everything is a Kubernetes resource behind the scenes. The beauty of this is that you can do things like this. And here's the Visual Studio Code, for instance. I can go here and do pause like I would do with any Kubernetes deployment or any Kubernetes thing. So it's paused, it's frozen, there is not using resources. You can do preemption of resource. So there's a bunch of administrative tools that you can do. Everything that you can do in Kubernetes, you can also do in Kubeflow. And as an example that I love to share with you is how people do actually data science. I'm not a data science, okay? I always joke with Elder that I'm jack of all trades and master of none. You know this, right? And so why people retrain? Why people usually retrain a model? Imagine that I'm Python. No, Python. Go. Yeah. So usually people do this in machine learning. I'm taking here a pre-trained model. Your company in practice will not train a model from scratch. You take one model that you have and retrain a model. And when I retrain a model, I'm here using the model that's popular for object detection that called YOLO, is that you only look at once. But what this model is pretty good is to identify objects, for instance, to identify cars. And when you go here, I go this picture, and I can even identify multiple objects. This number here is the probability that this is a car, okay? But imagine that you work for an insurance company, for instance. This model is pretty good, but your insurance company wants to see if a car is crashed, like to see if a picture is correct that the people put in your application. You're building an application, people upload pictures of car crashes, and you want to see if there is actually a car there. When you take those models, for instance, for an accident, you take this picture, the model cannot identify that this is a car. Okay, because the model is trained with things that are not accidents. So people that are data scientists, they take things like this data set, they take these samples, and you have a bunch of images. I hope this is interesting, because it was interesting when I figured out what people actually do. And they take a bunch of this data that is called data that is trained, and this is for privacy reasons. Probably there is a person here. You see that there is this accident of the car here. So what they do, they fed those images in a model, and everything go with a label. So if you go in a label of the picture, this is normalized, but it's actually the box beyond the car. So you take like thousands of pictures like this, like you take another one, and you, this is the same, you take another one, show the different one. So this is another accident, and someone that is a human go there and train. I'm trying to supervise the machine learning. Someone draw a box here manually. I fed this to my model. After I fed to my model, remember, this is the new data that's coming. And then I fire the pipeline and I do the training. After the training, the model is populated, and I can go there and do something like this. Now I'm taking the model that I did retraining before coming here, so it's the output of our pipeline, okay? And do the same thing, and I started to be able to identify car crashes. So this is the same picture. I'm going there and identifies a car crash. So when you hear that a data scientist is trying to retrain a model, you actually are doing this. Imagine that a new type of car appears, or your company starts to detect like motorcycles. This is when you have to take input data and fire a retraining pipeline of your model. Okay? Are you following me? This is, I think, it's super interesting to understand how machine learning works. But coming back for more financial industry, because people with Java, they love financial industry, right? How people, let's go for the fraud detection example. That will be the Elder will continue. So I have here another, I can get, on the slides I will share, there is a tutorial that you can follow online on OpenShift and do. So imagine that you are a fraud company. This is the training code. So you have these features, that is the parameters in Java, okay? That is coming from the data. Is the distance from home? Is the distance from your last transaction? Is the ratio to median purchase? If the person buy already in that retailer, so it's repeatable. Use it chip, use it PIN number, online fraud orders, and online fraud. And in order to, this is the input, this is the feature that I want to train. And in order to train this, fraud detection, no, it's not here, it's data. This is a big one. So this is a CSV of, is a huge to open here. So I do fraud detection. So I do a tail here. So remember that I told you that is a trained data. So this trained data is basically, this number is not so simple because you are normalized. One thing that people do in machine learning, usually when you have a number that's go for 100, 0 for 100, to do average, they minimize everything to 0, 1, to be a better statistical thing. So this is the same data that is used that, and people transform the data, and in the end see that this 1, 0, if this transaction is actually a fraud or not. So you take, we have here 14 megabytes of a CSV of those transactions. A data science go there, train the model, sees all the things that the data science does a transaction, In the end, this is training, and in the end, I save a model file. This model file is the model file that was trained that will be deployed on the key serve. So here's a testing of the model. So in the end, will be a file. When I test the model, for instance, this is the metrics of confusion, is to see if a model is working or not. People statistics does this. So how I use this? Imagine that I pass the input data and do a prediction. For instance, is Sally transaction fraudulent? It's false. And what is the likelihood? Remember that we mentioned that it's not 0, 1, it's our probabilities. So there is a likelihood you need to share, you take a threshold of what you accept. So this is a way, I never taught this, I know how this stuff works because I did some courses, but it's not for our audience, it's just for us to understand what people does to train a model. After this, you go, here you can see the execution of a pipeline, for instance, that I show you. Here I put a long pipeline running. And then I go in model serving is actually where my model will be deployed. Okay, so I have an inference endpoint here, an endpoint. I will go in the REST request. So everything becomes REST now. So don't be afraid about people will be left. Everything will be REST in the end. And what is the best language to consume REST endpoints in Kubernetes? We know that is Java. So yeah. And so everything will be REST. In the end, if you are near the Kubernetes, you become much better than this. So how this works, I'm doing a REST endpoint here in the end. That will be this URL. That's the same that Elder will use. So when I go in input data, this is where I take the data and scale to become between 0 and 1. I'll give you an example here. For instance, user buy a coffee. Same location, same median, using the PIN number, using the credit card chip, you understand that this is the data, the feature that I have from a fraud transaction. Then I call my model, and my model replies with this confidence that 33%, and I think that is below my threshold, so it's not a fraud. If I put like I try to be like this. Okay, yeah, it's you understand, yeah, Elder show later. So it's how people do is a fault. And behind the scene, how this works. Now I will break my terminal. So if I go for inference service here, see that there's a fraud here. This fraud is a service in the Kubernetes, but it's called inference service. If I enter here, you can see all the Kubernetes resource that I play. Remember that we push like the model format in deployment, you pay how many gigabytes, how is the processor, mass. I do this push, what the platform does, do this push for the Kubernetes, and behind the scenes, Kubernetes creates the containers. Create a deployment first. I have here my fraud talk prediction. Remember that picture that I have a fraud detection? If you enter here, you see my container that's key serve running, and here is where I'm hosting the model in the end. So the model file that's produced for the output is actually running inside this container. Now you can see why Kubernetes and Kubeflow is so good to do this sort of stuff, because we have all the infrastructure that Kubeflow does, and Kubernetes does put abstraction for the data science in the top of the Kubeflow in order to create their production. Now, my friend Elder, I confused the Elder is too much elders. We explain how Java programmers can benefit from this and why Java is a good option for this. And we are going to do the trick here to swap the monitors.
Even we got confused with
You work it.
Well, Elder showed you Eder. I know I got confused with our own names. Well, guys, as Elder told you guys that in the end of the day, we are all working with REST APIs, and we really believe that one of the best options, if not the best option that we have for consuming REST APIs today, is Java, of course. And not only Java, but these days we have this framework called Quarkus. Anyone here is using Quarkus already? Okay. In production? Okay, awesome, great. So you are using cases. And well, let's have a briefly cover around Quarkus. So it's a Java stack for working with cloud native, microservers, and serverless. And of course, if you are building monolith, it's also as the same way. And it's interesting to mention serverless because Eder just told you guys that the models that we are serving here are being served as serverless, in the serverless approach. So we are always connected here with this approach. And maybe you guys already heard that Quarkus is the subatomic and supersonic and subatomic Java. And here's why, and here's how Quarkus is doing that. Because what we did at the end of the day, we take this whole actions and processing and so on that happens on runtime, on regular Java frameworks, and we took it to the build time. So instead of figuring everything on runtime, we move what is possible to move to the build time. Okay, and it happens the same when we are talking about native compilation with Java. So we are doing the same build time, and we do the packaging, and okay, we choose if we have a native executable exit, an output, or a JVM way. And most important here, everything that we do in Quarkus is Kubernetes native. So we went beyond the cloud native approach and build everything in Quarkus on Kubernetes native way. So you are assured that whatever you do in Quarkus is already ready to work on Kubernetes. And this is so important, especially for our demo today, because we are pretty sure that everything here will work on Kubernetes, all right? And also important, and here we have a picture of the Eder back. Okay, so he's doing his push-ups. And we have a good and an awesome integration with the main and the most important open source projects in the world. Okay, so if you are a Spring developer, you can use Quarkus. If you are a Java developer, you can use Quarkus. If you are a microprofile developer, you can use Quarkus. If you are a Camel developer, you can use Quarkus because we have all the extensions for these projects already implemented inside Quarkus. Okay, so Eder showed you guys this fraud detection model that he trained on his infrastructure. And here we have a way to consume this model for fraud detection using Java with Quarkus. So here, let's check. Okay, so our demo fraud, I will show you very quickly the code, just to show you guys that it's a very straightforward Java application. So we have here our resource, our REST API. Okay, so we have a path. Here we have our URL for the inverse module. And here are all this logic for doing stuff here. I don't have too much time to explore all the details, okay, so just to show you guys what we have here. So let's run. This is the fraud. Okay, so again, Quarkus dev.
So in the same way that you consume any REST API, you're going to consume right now the fraud detection key serve.
And here's the deal, because why we built this whole session here, guys? Because we truly believe that our job as developers, especially we're gonna talk about AI more and more in the next times. We'll have this conversation, developer dealing with the MLOps guys. So how we have the same vocabularies, how do we work together? So that's why we built this session, to explore this whole aspect of this development these days for you guys. So let's run here. So this is the dev UI for Quarkus. So here I have all the context of all what's happening with my application here, so I can run tests, I can see the extensions that I'm using. I'm not going into too much details, but I have here the Swagger that I added to my project, so I can call my my endpoint here. So let's try out. I have here a guy here, okay. So what I'm sending right now to my module is that I have a transaction here. Other explored it, but I have the distance from home, the last transaction, the ratio median purchase price. I have, if I'm buying again from this retailer, if I'm using the chip or pin and so on. So here I'm not using the chip. So here my transaction, okay, the module is saying that is not a fraud. So I can play it with this calling here. So maybe I'm not that close to my home right now. And the distance from the last transaction is 1,000, and this then not the is my first time on this retailer. So if I change it, and right now this is 90%, 95%, no, 100% chance that this is a fraud. So according to all the data that is in my model right now, we can have these results here. Here, guys, I'm using just plain old Java running on top of Kubernetes, on top of Quarkus, okay? Of course, we can run on top of Kubernetes. These days, we have been listening a lot about LLMs, so large language models. So what we showed you until right now in this talk, it's all about predictive AI. So AI built to do predictions. So we have already the generative AI, so AI to generate content, generate whatever we needed. And for that, we have a very, very famous project these days. People have been talking a lot about this. That is LangChain4j. So let's talk a little bit about it. Anyone here is already using LangChain4j? Yeah, perfect. Anyone tried? No, hello world. No? I tried. Okay, awesome. So let's briefly exploration about what is LangChain4j. Let me check the time. So basically, when you talk about LLM providers, we have a lot of options, of course. And as we have a lot of options, each one of them, they have their own APIs, their own way to do stuff, and so on. So for us as developers, it's a pain to just need to learn all these models and so on. We have new modules on every day. So one of the main approach of LangChain4j is to build a single way, a unified APIs for you to access whatever model you want to access, okay? The second aspect is they are really working to let the stuff ready to use. So by letting you to use prompt templating, memory management, that I'm going to show you how to do this, to build the agents, to work with RAGs, and so on. So everything to make our lives as developers easier, okay? And Java, because, you know, Java is fun, and that's why we are here. And let's go to two more demos here. And the first one is our modules.
Yeah, while Elder set up them, all the models that we're going to consume right now are running the same way with the keyserve, absolutely with a bunch of more resources. That's why we're using the cluster, but behind the scenes are the same keyserve API that we are querying.
And the funny here is what where we were building this presentation, asking, hey, Heather, come on, give me a DeepSeek module. Okay, DeepSeek module. Hey, give me a Llama module. Hey, here's a Llama module. So that's why this whole infrastructure that we have here is so interesting. Uh, let me show you how we build this agent. Kind of, it's not exactly an agent, but first, when you are using LangChain, you will need to register an AI service. Okay, so that's what I'm doing here. So I create, it's an interface, okay, very simple interface, that have a chat module, a chat method here, sorry. And one aspect very important in this presentation here is this guy here, the module name. And I'm going to show you why this is important. But just, let me just show you our resource. Is a plain REST API again, okay, just receiving a prompt that is the message and send the message to the module, okay? The secret here, the so much important part here of this demo is all these properties, because I created a simple applications property for each module. So let's start today with our OpenAI, because I will show you what's going on here. So let me just refactor to use the OpenAI. And then clean Quarkus dev. So what do we have in this properties file? So basically, remember that here in our AI service, I have this module name. It will work here like an alias. Okay, so I define here this demo model. So you can check here demo model, demo model, demo model. Because I defined that the way that I will communicate with the models is by using an OpenAI provider. So that's an approach to access whatever model. So here under the hood, LangChain is handling all the communication with the model for me, no matter which model I'm using. Okay, so this is so interesting. So I have here all these properties that I'm not going to explore. So let's check how to access here. This is the guy. So here I'm accessing OpenAI, right? So I can ask whatever question. Do you guys have whatever question to send to the model? What's the best language in the world? I don't know. Let's check here. So, what's the best? I have a good one. What's the best Java conference in the world? Let's see. Determining the best Java conference can be Siberian. Okay, he will be polite and not say name, but Java 1, Devnexus, JFocus, QCon, QCon guy here, JAX, Oracle 1 doesn't exist anymore. Okay, no problem. But well, just an example how to access the module. But the good part here is that if I need to access another module, just for the sake of our presentation here, I can just change it here to another properties. This is the OpenAI. I will move to, I don't know, DeepSeek, because Ether trained it for me. So I have a DeepSeek. Ether is serving this module for me. So I can send the same question, for example.
This will be one of the great things of Java, that you can quickly swap with Quarkus, which type of model that we're consuming can serve, like properties.
Yeah. And this is the most important part for me, because just by switching the properties, I can change the whole behavior of my application. What's the best programming language in the world? Spicy. He will say Python. Oh, good. Let me check. Come on, guy. I know that you can make it. He's trying to be... Oh, and DeepSeek, I noticed. And this is interesting when you are using different modules, because you can notice the different behaviors of each module. So DeepSeek will take more time to figure out what to answer, how to answer, and so on. I believe that's why he's taking to here. We have here think. So okay, I'm trying to figure it out, and so on, and so on, and so on. So it takes a lot of time. Until here, it's just thinking how to answer the question. And here we have the real question. Okay? Okay, great. So well, if I can prepare my application to access whatever model I need, why to not have one application really accessing many modules? So that's what I will show you in the last demo. It's the demo multi-modules. So how did I do it? Whatever, how I did it. By doing this. So I created a one single properties file, and by using that alias for the AI service, I can access many modules. So I have OpenAI, I have Granite, I have Llama, and I have JLlama. Okay, so I have an inference module running 100% in Java these days, and in my case, it's running here on my machine. Okay, and for that, I need to create one AI service for each module, but it's really the same service. Just made a reference for different alias here, so for JLlama and so on, for AI service. And one thing, I don't think we have enough time, but just to show you guys that I prepared prompt templating, so just using system message that will define the behavior of my AI service, and the user message, that's the real prompt templating. And the funny part will happen here. So I will send the same questions to 4 modules so we can check the difference behavior for them. And let's open here. Swagger AI. Okay, Elias, which question can I send to the module? Whatever question you...
What is the best conference?
No. United States? Okay. What's Java conference, programming conference? Java conference. Okay, lots. The best Java conference in the US. And why he thinks about the question, let me just show you that I defined a system message that, hey, you are a system that has been compared to another systems in terms of consistency and conciseness. Yeah, precision and conciseness. Okay, so each model will try to answer the questions in a very concise way and a very precise way. And here I defined that it should be short answers. So let's check the results. So Granite, he always ignores my my messaging, so he's not concise at all. We try to be polite and so on. Okay, mention Java 1, Java World, Java user groups, not a conference, man, come on. Devnexus in the US, not gonna happen. Spring 1, yeah, okay. Llama is concise. Some of Java conference US, Java 1, Java 1, Java 1. Oh, come on, man. Java 1 is no longer held in the US. No, it's held in the US, but okay. OpenAI, okay, it's Java 1, San Francisco, yeah, not really. Devnexus US, not really as well. And JLlama. But the point here is, you can, of course, you not send these questions on the real application, but you can have the experience. Imagine that you have modules fine-tuned for different specialized ways to use the modules, so you can have your application accessing all those modules and have a single behavior for your application. So let me bring...
Yep. And so in the same way that the DevOps pipeline revolutionized a way that to develop software, I hope that we should be able to share with you 2 important things. First, that I talked with Elder, that I would like to share with all the Java audience how those pipelines work under the hood, and especially to also see, because it was my concern in the beginning when I started this journey, that Java doesn't have a fit in this picture. And as much as I understand and start to work on this, I understand that Quarkus and Java application, especially on the top of the Kubernetes, is still the best tool for you to write your AI Java application. So when you see about the enterprise, you're actually writing a lot of Java applications that are consuming a lot of models and they can serve. And now you have also vocabulary to understand that we didn't show here, but you can retrigger a pipeline here because you just do a custom resource and do a push in Java with Quarkus. You can do this, and you can do all the pipeline and retrigger, so you can have the control for our application, for your metrics, all the control for this pipeline in the Kubeflow. And I hope this talk was useful for all, and thank you so much.